All right, friends, we're going to jump into the next section of Chapter 8. And before we moved on, I know we've been doing a lot of work with ratios and proportions, but I wanted to remind you that this chapter, Chapter 8, is actually on similarity, okay? So if you remember at the beginning of the chapter, we had a definition for similarity. This is Chapter 8, Section 3. And what y'all define similarity is basically when two things share characteristics but aren't exactly the same, right? That two things can have some of the same characteristics, but they're not necessarily exactly the same. So take these two pictures, for example. Can you tell which of these is an alpaca and which of these is a llama? Alpacas and llamas share a lot of the same characteristics, but aren't exactly the same. We would say they are similar, right? In case you're wondering, these ones over here on the left are alpacas, and these ones over here on the right are indeed llamas. And we can just do a quick Google search on the difference between an alpaca. There we go. And when you read this, you can see that, well, there's differences between their ears, and the llama is about twice the size of the alpaca. So like we thought, these two things are not the same, but they're very similar. And even though this is a funny example featuring funny-looking animals, the same thing is true in lots of math between shapes, that we can have similar polygons that have a lot of the same characteristics, but when you get down to the nitty-gritty, they're not exactly the same. Okay, so we've defined similarity in general, but when we get specific to polygons, we define it like this. Similar polygons are two polygons that have corresponding angles that are congruent and corresponding sides that are proportional. Okay, I'm going to say that one more time, and I really want you to think about what this is saying. Two polygons that have corresponding angles that are congruent and corresponding sides that are proportional. So if this is the symbol right here for similarity. This means these two things are similar, and we already know that when we list something like A, B, C, D, that's indicating a quadrilateral. So what this whole thing is saying is that the quadrilateral A, B, C, D is similar to the quadrilateral W, X, Y, and Z. So if ABCD is similar to W, X, Y, Z, then because they're two similar polygons, we know that all of these things are true. And we're about to list them, okay? Corresponding angles are congruent. Here's what that means. We have angle A. What is the corresponding angle A? What is the corresponding angle to angle A in this shape right here? Well, it's really easy to tell that the corresponding angle is angle W. So since these two things are similar, we would say angle A is congruent to angle W, because those are corresponding. They're in the same general location in the shape. Obviously, this is the upper left angle, and this is the upper left angle. These two angles are corresponding angles. They correspond to the same location in each of these quadrilaterals. So we can go around and do this for all of the corresponding angles. Obviously, B here is corresponding to X. So we would say angle B is congruent to angle X. D is congruent to Z, because those are corresponding. And finally, angle C is congruent to angle Y. Okay, now, the next thing that it says is not just that we have corresponding angles that are congruent. It also says that the corresponding sides are proportional. Now, let's talk about what that means for a second. What does it mean when two things are proportional? We've just spent 2 sections writing ratios and proportions. What does it mean to say that two things are proportional? Well, it means that the relationship between them is going to be the same. So here's what I mean. If I look at AD what side is, first of all, is corresponding to AD in this shape over here? Well, clearly it's WZ. And mathematically, what it means to say that two things are corresponding, are proportional, it means that when I compare the mathematical relationship between AD and WZ, that's AD, the length of AD divided by WZ, that will be the same as the relationship between all the other corresponding sides. So remember, when I write 2 points like this, it means the length between A and D. What this is saying is the length between A and D over the length between WZ will have the same relationship as all the other corresponding sides. AB corresponds to WX. So if AD and WZ have that relationship, then if these two things are proportional, we know AB and WX will have that exact same relationship, that when I divide AD and WZ and I divide AB and WX, those proportions, those ratios should be the same. And we can keep going, that the relationship now between BC and XY will be the exact same. And then lastly, similarly, the relationship between DC and ZY will be the same. All of these relationships between, this is what it means to say the corresponding sides are proportional. All of their relationships to each other will be the same. The difference between AD and WZ will be the same as the relationship between AB and WX will be the same as the relationship between BC and XY will be the same as the relationship between DC and ZY. Okay, so now that we've gone over an overview of what similar polygons mean, let's actually look at a problem. This question asks, are the polygons similar? Well, just as we just said, in order for these two polygons to be similar, we must meet two qualifications. Those qualifications are the following two things. All of the corresponding angles need to be congruent, so we need to look at each angle. D corresponds to Z. Are those the same? Yes, they're both right angles, so those are congruent. A corresponds to W. Because of the arc marks, we know that those two are congruent. B corresponds to X. Because of those arc marks, we know that those are congruent. And C corresponds to Y. Once again, because of the arc marks, we know that those two angles are congruent. So in order for us to be able to say whether or not they're proportional, they are similar, we need to now see if the corresponding sides are proportional. So let's just look at these first two corresponding sides. Let's look at AD and WZ, okay? AD, the ratio between AD and WZ is 6 because that's the length of AD over 3 because that's the length of WZ. So it's a relationship of 2 to 1. So in order for these two quadrilaterals to be similar, all of this set of corresponding sides have to have a relationship of 2 to 1 in order for that to be true. So let's just look at the next two sides, AB and WX. AB over WX is 10 to 4. And there you have it right there. That is not a 2 to 1 relationship. In fact, that's a 5 to 2 relationship when we simplify. And because these two ratios are not the same, then that means that those sides are not proportional. And thus, since they're not proportional, these two polygons are not similar. We could keep going. And let's do that just for practice sake. BC and XY is a 12 to 4.8 relationship. That's also not 2 to 1. So that would be more evidence that these two quadrilaterals are not proportional. And DC to ZY would be 9 over 4.5, which that is a 2 to 1 relationship. But it doesn't matter because in order for these to be similar, every single pair of corresponding sides has to have the same relationship. And since two of them do, but two of them don't, it doesn't matter. These polygons are what we would say they are not similar. All right? They are not similar. Okay. A couple more practice problems and then we will be done. This time, it tells you that these two polygons are similar. That's what this means. Remember, this says ABCD, quadrilateral ABCD, is similar to W, X, Y, and Z. So what it asks us to do is to find AB, find XY, find YZ, find M, and find the perimeter of each. So we're going to do this together really quickly. And what I'm going to start with is I'm going to see, okay, are there any two corresponding sides that I know? Yes, I know AD and I know WZ. Those two are corresponding sides. So the ratio of AD to WZ is 6:4, which obviously simplifies to 3:2. Okay? So since these are similar, these quadrilaterals are similar, that means that every single side, every single pair of corresponding sides has to have this 3:2 relationship. So if I need to do something like find lengths of sides, then what I need to do is set up a proportion with this as one of my proportions. Here's what I mean. If I'm looking for AB, which is right here, I don't know what it is, so I'm going to call it X. I do know what its corresponding side is. That's WX. And even though I don't know what AB is, I'm about to sneeze. Woo. Even though I don't know what AB is, what I do know is that AB, which is X, over 5, its corresponding sides, has to be equal to a 3:2 ratio. And now I can cross multiply and solve. So when I do that, I get 2x equals 15. And x is 7.5. But remember what x is AB. So we've done this one. We can cross that off our list because we found AB. AB is 7.5. And we need to keep going around to find XY and ZY or YZ. So we need to do the same thing. Here's BC. BC is 12. And 12 over XY has to equal 3/2. You can work out this proportion, but when you do, you will get that XY equals 8. And then down here, again, DC is 9. Whoa. DC is 9. Corresponding side to DC is YZ. And in order for DC and YZ to have a 3:2 ratio, if you do the math, you will get that YZ has to be 6. Okay? So you should set up these proportions and solve just to make sure you understand what you're doing. But if you do this right, you should get that XY is 8 and YZ is 6. Now, the last thing it says is to find M and the perimeter of each. Well, in two similar shapes, once again, we were given that these are similar. What we know is that the corresponding angles will be congruent. This angle is 72. This angle is 4m plus 12. So those two things have to be congruent. So in order to solve for m, I need to set those two values equal to each other and solve. And my first step from here to here is going to be to subtract 12 from each side. And when I do that, I'll get 4m equals 60, and then I need to divide both sides by 4. And when I do that, I'll get that m is 15. Now, it says, last step, it says I need to find the perimeter of each. And when I find the perimeter of each, remember x is 7.5. We discovered that xy was 8 and that zy was 6. So when I find the perimeter of this one, this will be, I'll pull out my calculator. The perimeter of ABCD is going to be 9 plus 6 plus 7.5 plus 12, which is 34.5. So I'm going to write that down over here. the perimeter of this is 34.5. And when I calculate the perimeter of this, I need to add up all the sides. That would be 6 plus 8 plus 5 plus 4, which is 23. So again, I'll write that over here. And scale factor down here, you can see that written here. A scale factor is basically how much bigger is one shape than the other. Well, you might have some intuition about this, but guess what? If I divide the perimeter of one shape from the other, guess what this should reduce to? Well, it should reduce to the same ratio that I've been getting this whole time, which is 3/2. And in fact, this does reduce to 3/2. And that is what this scale factor is. The scale factor from one shape to another is essentially how much bigger is one than the other. This one is 3/2 or 1.5 times as big as this one. That is the scale factor. And what Theorem 8.1 says is that when two quadrilaterals or two polygons are similar, then the perimeter will also share the same scale factor as the corresponding sides. So if the sides have a relationship of 3:2, guess what? So will the perimeters of these two shapes. Pretty cool. So what I have for you last is I have a little honors problem, but what I would like is I would actually like everybody to try this. These are two triangles that are similar right here. It says they're similar, and what it wants you to do is to find all the possible values of x. This is a tough problem, and you don't have to do this, but I would like you to try it. And I'm going to check to see that you tried it and you did some of the work. So please try this problem. But even if you don't get the answer, if you get the answer right, I'll give you a reward. But even if you don't get the answer right, I still need to see that you at least tried this. Okay? So try this problem on your own. And I will check this when I see you in class. And then what you need to do is you need to do the practice problems that are listed on the Power School page for Chapter 8, Section 3. Thank you guys for watching this lesson, and I will see you in class tomorrow.